try and work out what's happening to this limit, right? And so far we've been using like funky algebraic approaches and sort of tricks with trig and radian measure to try and manipulate this. But there aren't really many tricks with this. You just sort of have to bash it out, okay? Now, rather than getting you guys to get your calculators out and really bash it out, I'm going to get Excel to bash it out instead, okay? So if you've never used Excel and like formulas in Excel, then hold on to your hats, okay? It's actually very, very powerful and very useful, okay? So let me show you. First, I want to think about values of h as they're getting smaller, okay? Now, I could actually just put in some manual values of h that are getting closer and closer to 0, but instead, I'm going to get Excel to do the work for me. So here's what we're going to do. Let's start at a value like, say, 1. 1 is not a big number, so this is good. As I get further down, I want to have numbers that are smaller than 1. So I'm going to take that number, see what I did, and I'm going to divide it by 2. Okay? So I'll have a half here, and then I'll have a quarter and an eighth, and they're just going to progressively get smaller. Okay? So there's a half, and I'll take that, and I'll just paste it in. Whoops, not that far, sorry. Let's paste it a few times. Okay, so we're getting some pretty small numbers, yeah? In fact, so small that Excel can't handle them. So that's scientific notation there. Okay. So we've literally got values of h that are approaching 0. Okay. Now taking the limit means, okay, tell me what happens to this whole weird fraction as these values change. Okay. So what have I actually got? I've got 2 to the h minus 1 on the top. So let's start a bracket here. 2 to the power of, and I want the h, which is just this value over here. You see that? Is that okay? To the h minus 1. Okay? How's that look? Does that make sense? That's my numerator. And then I'm dividing by h, which again is that same number. Okay? So before I press enter, the formula vanishes. Do you see what I'm doing? A2, it's because it's A and this is the second row, right? That's just my h. And then this will be the next h, and then so on and so on and so on. Okay? So there's one value. Okay? Now you're like, oh, is that it? Well, actually that makes sense. 2 to the 1 minus 1 on 1. So actually that makes sense. So now, here's where the computer does all the work. I'm going to get all of those for all of these different values of h. So let's go down a bit further. I'm going to go there. And I'm going to paste it. Okay? Alright, now. Let me bring this up. Okay, so what's can I scroll? Yeah, I can. What's going on? Well, for starters, this limit, it's getting smaller, okay? Which sort of makes sense because this number is getting bigger, right? But so is this one, what you're dividing by, okay? So it's getting smaller and smaller and smaller, okay? But then, you know, from here to here, you've lost like 0.18, okay? That's how much smaller you've gotten. From here to here, you've lost about 0.07, and then here 0.05 and 0.02, and then 0.008. So in other words, as I go step by step, I'm losing less and less. Okay? So I'm not getting smaller forever. I'm actually approaching something. That's why we're using a limit. Okay? So let's keep going. As the numbers get smaller, and I could keep going if you like, it starts to hit a brick wall, right? You notice all of these ones I've got on the screen, the first 3 digits are all the same. Okay? And I can keep going and they'll stay the same. And then you've got very, very minute changes. Okay? Now, evidently I'm approaching some number. 0.69314 something something something. Now, you guys probably, that number doesn't mean much to you, and there's not much of a way for me to say, well, okay, don't you remember this number? It's very common. Okay. This number is, now you can get your calculator out if you've got it there. It's not a square root. You can probably move the angle of that back to the board if you want. You can try. This number, it's not E. E is 2.7 something or other. Okay. What is this number? It's related to E though. I want you to get your calculator out, and I want you to type in. Have you got it there? I want you to type in. Oh, wrong one. Sorry. This will have to do. On your calculator, I want you to type in natural log of 2. It's 2 because this number, okay? Now, exactly, how close did I get? It's 0.69 what? 3, 1, 4, 7, what? 1, 8. So I got pretty close. I got, you know, a lot of decimal point places close, right? So that's what this is approaching. I could keep on going if you like. Excel would eventually run out of decimal places. This is my limit, okay? Now, hold on a second. What was the significance of this number again? This number, this log 2, corresponded to what this limit was approaching, okay? This whole part here. So this derivative is therefore equal to 2 to the x times log 2. Natural log of 2, I should say. Okay, now, that's kind of interesting, I guess. What significance does it have? Well, you can try this out again, alright? And you can put in 3 to the x, or 10 to the x, or whatever number you like, okay? You're going to get this same thing being able to come out the front. So for example, if I change this to a 3, this would be a 3, a 3, a 3. So I would again factor out a 3, and then I have 3 to the h here, okay? And I can crunch the numbers if you like. You'll get 3 to the x log 3.
Whoa.
Okay? You can check it out, right? So something's going on here, right? Now, here's my pattern. Let's generalize first. Maybe you're not that content with the fact that I used a computer to do it, okay? But it's sufficient for us. That if I differentiate any kind of exponential function where it's some constant to the power x. So let's call the constant a. Okay, power x. Yeah, it's super new. Okay, so that's going to give me, well, let's think about this. What's log 3? It's just a number, isn't it? So the derivative is the exponential function times some number, right? And that's what we expected by our intuition, that the derivative is another kind of exponential, but not exactly the same. And that not exactly the same is this log a number. Okay, you should probably add in where a is a real number. So that's to distinguish it from x. X is a variable, but a is an actual number that belongs to this set.